In this video segment, we'll be discussing about queue data structure, enqueue and dequeue operations, implementation of queue using array, and the algorithm. Queue data structure. Queue is a linear data structure. A linear data structure means a data structure in which elements are stored sequentially or linearly. Inside the queue, there will be a collection of homogeneous data elements, that is, data elements of same type. Insertion and deletion take place at two different ends inside a queue. Queue follows a FIFO order, first in first out order or last in last out order. So queue is a linear data structure in which insertion and deletion takes place at two different ends. These are some real-world examples of queues. We can see queues at banks, shopping centers, ATMs, etc. In all those queues, the principle followed is first in first out order. The same principle is used in our queue data structure. Now let us discuss about the operations in queue. First one is insertion operation and second one is deletion operation. The insertion operation is called as enqueue and it is normally done at the rear end of the queue. Deletion operation is called as dequeue and it is normally done at front end of the queue. So these are the two operations in queue, insertion and deletion. Insertion is called enqueue and it is done at the rear end of the queue, and deletion is called as dequeue, which is done at the front end of the queue. So this is a diagrammatic representation. We have a queue here with two items. Whenever we want to insert a new item, we will enter it in the rear end of the queue. Whenever we want to delete an item, the item is deleted from the front end of the queue. So the insertion operation is called as enqueue and the deletion operation is called as dequeue. Insertion at rear end called as enqueue, deletion at front end called as dequeue. Queue data structure can be implemented using two methods, a static implementation and dynamic implementation. The static implementation is done using an array and dynamic implementation using linked list. In this video segment, we are going to discuss about implementation of queue using array. A queue data structure can be implemented using a one-dimensional array. Initially, the front and rear variables are set to -1. Whenever we want to insert a new element into the queue, first we have to check whether the queue is full. If there is space in the queue, you can increment the rear by 1 and then insert the new element at a position. Whenever we want to delete a value from the queue, then increment front value by 1. So these are the basic principles for implementing a queue using a one-dimensional array. Now let us discuss the algorithm for enqueue operation, that is to insert a value into the queue. Start. Check if rear is equal to max size -1. This is to see whether the queue is full or not. If queue is full, we cannot further insert any element. If there is space in the queue, go to step 3. In step 3, check whether front is equal to -1. If front is equal to -1, we can understand that till now no element is added to the queue. So in that case, front and rear is to be set to 0. Afterwards, insert the element into the rear position. Now if front is not equal to -1, already some element has been inserted into the queue. In that case, go to step 4. Increment rear and insert the element into the rear position. Stop. So this is the algorithm for inserting a value into the queue. Now let us discuss the algorithm for dequeue, that is to delete an element from the queue. Start. Then we have to check whether the queue is empty or not. For that, we have to consider two situations. So the first one is front is equal to -1 and rear is equal to -1. That is the initial state of the queue. No elements are inserted till now. In that case, queue will be empty. The second one is front is equal to rear plus 1. This is a condition where already queue had some elements, but all were deleted. So if front is equal to rear plus 1 also, queue will be empty. If any of these two conditions is true, queue will be empty and we cannot delete an element from the queue. So a message should be printed like this. If the queue is not empty, an item can be deleted. In that case, assign a variable item and give the value of queue of front. Increment the value of front by 1. Then just display the item which was deleted. Stop. So this is the algorithm for Dequeue for deleting an element from the queue. Let us now consider an example in which Enqueue and Dequeue operations are done. Consider a queue with maximum size 4. Now we are going to perform these operations.